Hello everyone and welcome to our videos in Bazara Aviation Academy. Before we start our video today, I will answer the last homework. Did you answer the homework or do you remember our homework in the last lesson? The homework was which component of turbine engine gave a bleed air and what's the benefit of it? The answer is the compressor. The compressor gives us a bleed air. What's the benefit of that bleed air? The bleed air is used for cooling the whole section, and we have a heated air for anti-icing cabin and pressurization the cabin, and used for air conditioning and used for fuel de-icing, and the last one it used for pneumatic engine starting. Today our class will be from POWERPLANT book, chapter 3, and this is the second class. By the end of this video, I hope all the students can make difference between the classification of turbine engine and can illustrate the types of each component of turbine engine. And we will start with the first class of turbine engine, turbojet engine. How turbojet engine produce thrust? As we talked before, the air will come from the inlet and will pass to the compressor. After the air is compressed on the compressor, it will pass to the combustion. When it arrives to the combustion, the air will mix with the fuel and make explosion. This explosion will expand the air, and the air, when it's expanded, it will move to turn the turbine. When the turbine is turned, it will spin the compressor with it. After that, the air will pass from the exhaust. Here, the air outcome, it will be more than the air income, and that's what we call EPR, engine pressure ratio. So, in this time, when the air that goes from the engine, it's more than the air come from the engine, that means the engine will produce thrust, and this is the idea of turbojet, how to produce thrust. In a turboprop engine or turbopropeller engine, the engine will give power to the propeller. How that come? The air will come from the inlet and arrive to the compressor. After the air is compressed here, it will go to the combustion. In a combustion, here with the fuel, we will have explosion and the air, it will expand. When the air expands, it will move to the turbine and turn the turbine. After that, the compressor and the propeller will turn. So here in turboprop engine, we will care about the RPM more than reduced thrust. And here we have a reduction gear. Reduction gears here used for give optimum power to the propeller. Turboshaft engine is the same of turboprop engine, but it has a simple difference. In a turboprop engine, the turbine when it turns, it will turn the propeller. But here, when the turbine will turn, it will turn a shaft, and this shaft maybe is connected to the electrical generator and like what we have on the EBU. And also it will connect to the blades of the helicopter. Turbofan engine. How turbofan engine produce thrust? When the air enters the engine inlet, it will divide it into two separates of air. One of the separates, it will enter the core of the engine and will compress in the compressor. After that, it will go to the turbine, to the combustion section, after that it will expand and turn the turbine. When the turbine is turned, it will turn the compressor and turn the fan. After that, the air or the combustion air, it will go from the exhaust. After that, the air that or the second air that will go around the engine, it will pass from the engine. So we have here two types or two kinds of thrust. The first one that produced because of the combustion and because the combustion in the combustion chamber, and the second one that produced by the fan and that pass around the air. So here we have to understand two definitions. The first definition is called thrust ratio. What's the meaning of thrust ratio? The thrust ratio is the compression of the thrust produced by the fan to the thrust that produced by the engine core exhaust. This the thrust that produced by the fan, and this our thrust that produced by the engine exhaust. The second one we have bypass ratio. What's the meaning of bypass ratio? It refers to the ratio of air incoming that bypass the core to the amount of the air that passes through the engine core. That means it's the difference between the air incoming to the core of the engine and the air that bypass or go around the engine. After we understand how the classification of turbine engine produces thrust, now we will know the types of each component of turbine engine. And the first component is the air inlet duct. The air inlet duct type, the first one is subsonic, and this subsonic is divergent shape. And the second one is the supersonic inlet. And in the supersonic inlet, the shape it will be convergent divergent. And this type used for suction more air to the compressor. And the last type we have is the bell mouth, and this used on the helicopters. And now, what are the types of engine inlet mount? The first one of the engine inlet mount is the engine inlet. The engine inlet. And the second one is the wing inlet mount, and the last one we have is the fuselage engine inlet mount. Compressor is the second component of the turbine engine, and the compressor is classified to two types. The first type is centrifugal compressor, and the second type is the axial compressor. Here we have the first type of the compressor, the centrifugal flow compressor. The centrifugal flow compressor consists of impeller, diffuser, and the compressor manifold. The impeller used for increase the pressure and the velocity of the air. The diffuser used for decrease the velocity and increase the pressure of the air. And the last one we have the compressor manifold. It used for distribute and deliver air to the combustion chamber. Here we have the second type of the compressor, and is the axial flow compressor. The axial flow compressor consists of rotor blade and stator blade. The function of them, the rotor blade, it will work as the impeller on the centrifugal compressor. It will increase the pressure and the velocity of the air. And the stator, it will work like the diffuser in the centrifugal compressor, will increase the pressure and decrease the velocity of the air. And here we will say this. Here we have the rotor blade, and it works like, as we said, impeller. And after that we have this, the stator, and it will work like diffuser. If we see here, we will find here we have axial compressor, and here we have a centrifugal compressor, and this called combustion or compression compressor or axial centrifugal compressor, and this it will be as a third type of the compressor that used on turbine engines. Here we have the combustion section. And the combustion section, it must consist of one or more combustion chamber. Here our combustion chamber, and we need to have fuel injection system, and here we have this fuel spray nozzle. Also we must have ignition source, and here we have our flare or ignition source. Also we must have fuel training system, and here we have the fuel training system. Combustion section. Before the air enters the combustion chamber, it divided into separate air. The first one is the primary flow, and this flow will go with the fuel to inside the combustion chamber and ignite it and make the explosion. The secondary flow will go around the combustion chamber and will mix with the burned air that makes explosion for cool it and go to the exhaust section. And our air here, around the section, it will be 75%. And the air that will enter to the combustion section and make the explosion, it will be about 25% of the flow. There are three types of combustion chamber that used. The first one is the multiple combustion, and this our multiple combustion chamber. And the second one we called can annular, and this our can annular type of combustion chamber. And the last one we have is the annular combustion chamber. Turbine section. Turbine section consists of case, stator, shroud, and the last one, the rotor. The function of this component, we will start with the case. The case is used to restrict the turbine rotor or stator. In other words, we can say it will be as a housing for the rotor and the stator. Turbine stator, it has many names, such as a turbine nozzle, turbine guide vanes, or nozzle diaphragm. The purpose of this stator is to collect high energy airflow from the combustion and direct the flow to strike the turbine rotor at the appropriate angle. The third component we have the shroud. Here we have in the stator outer shroud and inner shroud. What's the purpose of the shroud? The function of the shroud is to retain and surround the stator and prevent the stator from vibration. The shroud is attached to the stator by two ways, either by supporting ring or by using welding or riveting. The last component we have is the rotor. The rotor here, when we say, is connect to the shaft, and between the shaft and the rotor we have a bearing, and we know what's the function of the bearing. Here, when the rotor is rotated, because of the air that come from the combustion chamber, it will make it turn, and when the rotor turn, it will turn our shaft, and this shaft is connected in turboprop to propeller, and in turbo shaft will connect to a shaft, and in our turbofan engine it will connect to the fan and the compressor of the turbofan engine. To attach the blade of the rotor, they use the CH.3 slots. Here we have our away, and this called a CH.3 slots. Here we can take our blade for maintenance or for repair, and after that when we back it to our stage, we will use this. We have this groove to come with this groove. After that, for secure, we will put this beam in this area. That's for securing. There are two types of turbine blades, either impulse or reaction, and the difference between them in the airfoil shape of the blade. And here we have the first one, and we call this impulse. We will say here the airfoil shape, and we can say the difference between them when we say the second figure. This our second figure, and this the airfoil shape of the reaction blade. Because the turbine is exposed to high temperature, so the turbine needs to cooling. One of the most ways of cooling the turbine components is by bleeding air that's come to the surface of the turbine components. Also, to cool the turbine stator and turbine blade of rotor, compressed bleed air can direct it in through a hollow blades out through a hollow in the tips and in the leading and trailing edge, and this way called convection cooling or film cooling, as we see here in the figure. The air comes from here, and here our tips that go from, and this our leading edge, and this our trailing edge, and this way we call this way convection or film cooling. Another method used by using porous high temperature material, and the blade air will move from it and cooling the blade, and this called transpiration cooling. And here we see this figure. Here we have the air that moves from this direction and will goes from this direction, and this called transpiration cooling. We have a material, and this material is a porous. We know the meaning of porous, so the air will come inside it and will goes out from this way. The last component we will talk about today is the exhaust section, and we know the exhaust section function is to route the gases of the engine. Now we need to know the component of the exhaust section. We have the first component of the exhaust section is the exhaust cone. The second one is the tailpipe, and the last one we have is the exhaust nozzle. When we back to the first one, the exhaust cone is consists from things. The first thing that we have is we have the inner cone. This our inner cone, and we have the outer cone, and the last one we have is called strut. What's the function of the exhaust cone? The exhaust cone used to collect the turbine discharge gases into a single jet due to the diverging shape we have here from the inner cone to the outer cone or outer duct. The second one we have the tailpipe. The tailpipe is an extension of the exhaust section that directs exhaust gases safely from the exhaust cone to the exhaust. And the last one we have is the exhaust nozzle. The exhaust nozzle used to provide the exhaust gases with a final burst in velocity. And we have two types of the exhaust nozzle. The first one we have is the converging design, and this our converging design. What about the second one is the converging diverging design?